the pinna is basically the shape of the ear that is asymmetrical, and that is going to cause a different filtering if a sound is in front of us, if a sound is directly above us, or if a sound is behind us. And the brain needs all these cues in order to provide us with accurate localization.
Hey everybody, Dave Lindbergh in Hong Kong with a new episode of THD Podcast. Thanks for tuning in. Today we have a second visit from Audioscenic. And the last time we learned about their virtual headphone technology. And this time they have something new that they're going to be premiering at CES, but we're going to get a sneak preview today about adding spatial audio into this virtual headphones. We're going to see if, like I say, do I got that right? Did I understand it, or was I not paying attention? But let's not forget, DB Enterprises, the company that I work for, we're going to be at CES, so we encourage anybody that's interested into embedded audio tech. We'll be presenting some high-end dynamic drivers, some cool directional microphone technology, some haptic technology, and a few other little tricks, so be sure to reach out to us. We'll be having a private suite at the Venetian. But let's not delay. Let's get into saying hello. All right, good morning from the UK, Marcos.
Good morning, David. Good morning, Simon. Well, I should say good afternoon to you. But
So
great talking again.
Simon's in Japan, so I hope everything's good over there. But yeah, so it's been, I don't know, a year or so since the last introduction. But maybe let's not make people wait. Let's kind of jump right into a presentation and tell people what's new.
Certainly. Thank you very much for the opportunity. And yeah, it's been a period of a lot of change in Audioscenic, a lot of growth. I think we basically grow like twice in size since last time we talked as a company. We are now like 35 people employed in Audioscenic, so we are considerably bigger, and we are also having like a greater commercial penetration, which is great. And I think today, basically, what I like to talk you is, what have we been up to, and where are we going, and what our technology can do for the users and for our customers. And so I will show you some slides, and please at any time stop me if you have any question. So today I'm going to take you on a trip through our Amphi Hi-D technology and how with this technology, we can achieve true immersion, okay? So what is the Amphi Hi-D technology? So Amphi technology is a set of algorithms for sound field control that are packaged as a software package that we provide to customers, okay? We provide this software in a business-to-business basis that we give it to ODMs and OEMs to create innovative products based on our technology. Mm-hmm. What our customers get, the user experience, is that just with speakers in front of the user, like for example, here we have diagrammatic representation of a soundbar, mm-hmm. we are able to provide two narrow beams of sounds to the user that give an experience which is hearing sound all around us, hearing sound above us, hearing sound close to us, a very realistic spatial audio experience. Okay, this is what the Amphi technology give us. So this is great because now with just having speakers in front of me, I can have the most accurate, the most natural spatial audio representation. Okay, and when I say the most, it's because I can be on the middle of a Atmos setup, right, without needing Atmos speakers. Or we can even do something that we're going to talk later. We can even render things like distance. This is something very particular from this technology, okay? We can render virtual objects that sound close to us, as well as virtual objects that sound far away from us, okay? It's something very, very powerful of our technology.
Does it require any special recording? Like, does it have to be Dolby Atmos, or you can render this from any recording?
Good question. So any spatial audio format would work, okay? Because any spatial audio format starts from stereo to surround to binaural recordings to very high level surround systems, like for example, Dolby Atmos.
Mm-hmm.
Because once we know the position of, for example, Dolby Atmos speakers, we can use HRTFs. And with these HRTFs, we're going to have a set of left and right 3D audio binaural signals that we will deliver through mid-air. Okay.
Mm.
So from that point of view, the technology is compatible with any existing and future spatial audio systems. So maybe let's revisit how this would happen. Imagine like we have traditionally binaural rendering with headphones. And very common use case for binaural rendering with headphones is when we are playing a first-person shooter video game, where basically we're using a headset, and with this headset we are immersed in the game, and the game engine is using HRTF to give us objects of sounds happening all around us. Okay, like for example, like we use the competitive advantage to know that our enemy is behind us. We're going to shoot at them before they shoot at us. No, so this is commonly delivered with headphones. Another use case when we use headphones is, for example, when I have my AirPods here, and with the AirPods, I basically connect to Apple Music, and Apple Music is delivering to me a binauralized version of Dolby Atmos. Okay, so this is great because I can wear my AirPods. But what we are doing with Amphi is that we are using a crosstalk cancellation algorithm, and a crosstalk cancellation algorithm is an algorithm that takes a two-channel binaural signal, delivers each channel to the respective ear, and cancels the crosstalk. Okay, so if I have my left channel, the algorithm delivers the left channel to the left ear, and the algorithm is very clever to know, oh, actually, when I try to deliver the sound waves, I have some leakage on the other ear. I'm going to cancel it because I want only the left channel to the left ear and only the right channel to the right ear. Okay, that's the crosstalk cancellation algorithm. And this is quite important because something I want to basically explain here is how do we need to achieve a very high crosstalk in order to deliver very accurate and realistic spatial audio. Okay, and in this slide here we can see what is the crosstalk CTC, crosstalk cancellation, which is the sound level in one ear minus the sound level in the other ear. Okay, this is what we want to achieve. We want to achieve a very high difference between the sound level that I receive here and the sound level I receive on the other ear, which on a nutshell is like creating virtual headphones, And this is what we are trying to deliver with our technology. Apart from that, there is another thing that we basically do with our technology, which is the use of machine learning listener position sensing, okay? Which is the fact that these techniques for crosstalk cancellation work on a basis where we have a sweet spot that is very, very small, okay? Because we are doing constructive interference delivery and destructive interference delivery. So in space, this happens on an area that is dependent of the wavelength of radiation. Okay, so what this means is that as we go towards higher frequencies, the area where this constructive and destructive interference happen is smaller and smaller and smaller. Okay, so what happens that historically crosstalk cancellation systems have only worked when the user was really on the middle of the setup. Okay, and that was a drawback because if we really want to make this technology accepted by people, which means we want to make it practical, what we need to do is that basically we make it user adaptive. And this is what we achieve in the Amphi technology by connecting our DSP algorithms with a machine learning listener position sensing system that would note where the user is with respect to the speakers and in real time adapt the position of the crosstalk cancellation to the user. Okay. So these three ingredients are key to give the technology.
So are we still using a camera as you were last time?
So camera, we are still using cameras. We are also using other modules that are a combination between camera and an AI head tracking system, okay? Which is basically an integrated module that calculates and does all the machine learning estimation on the device. And then we are also using time of flight systems, okay? So in Audioscenic Amphi, Audioscenic has its own head tracking software, but we are also able to work with third-party head tracking system.
Okay.
It's quite important. So once we combine all these things, what do we get? From a user experience point of view, we get the ability to control an HRTF and deliver the whole HRTF as we need in order to have good, accurate spatial audio experience. Okay, so let's just here take a look at this graph of an HRTF. It's an HRTF that is at 45 degrees with respect to a user. So, for example, to my left. And what we can see in this graph is that on the left ear, we have certain magnitude because the source is here on my left. So it's going to hit first my left ear. And then a bit later, it's going to hit my right ear. And so it's a bit occluded. It has less magnitude, less intensity because of the shadowing of the head, okay? So in this HRTF, there are two areas which are quite important for how do we localize sounds. And the first area is located at lower frequencies, and it goes from about 200 hertz to 1.5 kilohertz, and is the ITD region, where ITD stands for interaural time differences. In this frequency region, the brain analyzes difference in time arriving to both of our ears, and then the brain, thanks to that, is able to lateralize sources to say something is coming from here, something is coming from there, something is coming from there, something is coming from there. However, the brain is not able to understand if something is 45 degrees ahead of us or 45 degrees behind us, because the time differences at this angle are the same. And this is what creates the cone of confusion, where just only due to interaural time differences, we're not able to know if something is in front of us or behind us. So the brain, because it's very clever, uses other frequencies,
Right. I would just comment that I think I live full time in the cone of confusion. But anyway, that's a different topic.
Yeah, it's very
It's a funny name.
it's very common, and that's why it's amazing how humans we are so
No,
developed. And
this is interesting. I think we've actually had a lot of podcasts talking about hearing damage. And one of the common things with hearing damage is, and maybe you can tell us here, at what frequency range I think it's higher frequencies, people usually have hearing loss earlier, and that really impacts their directionality and to detect where the sound is coming from.
Absolutely, so the hearing damage, this in yellow here, I have put this part ILD and pinna region.
Yeah.
So this is the region where for sound localization, the interaural level difference, which is the difference in intensity, you can see how for a source that was 45 degrees with us, at lower frequencies, the level difference is kind of contained because the wavelength is very big and the head doesn't cause diffraction to the wavelength.
Right.
But as we go higher in frequencies, the diffraction effect of the head grows and we have a higher level difference.
Right.
And also very important, we have this pinna region, which in this case is located just below 8 kilohertz. The pinna is basically the shape of the ear that is asymmetrical, and that is going to cause a different filtering if a sound is in front of us, if a sound is directly above us, or if a sound is behind us, And the brain needs all these cues in order to provide us with accurate localization. And coming back to the hearing loss case, we start seeing more acute hearing losses around 4K, around 8K. And what this is making is that we are struggling decoding the cues around this 4K, around 8K. So that means that the brain is going to have a harder job really getting the information provided by the PINA and provided by the interval level differences. This is one of the main causes of hearing loss, and that's why hearing loss affects localization. Usually.
Interesting.
Yeah. There is another very important localization mechanism that humans rely on, which we haven't talked about it here, but maybe we can just mention it, which is the head rotation. Like normally, when we don't know if a sound is in front of us or behind us because we are on the cone of confusion, we do like that. Without us noticing, we do like this. And this is when we know, it's actually there, or it's actually behind, That's why incorporating head rotation, or what other people call as 6 degrees of freedom in spatial audio systems is very important.
Okay.
Little side topic, don't mind. So, you get your Find My Phone thing, and it causes your phone to make a bleeping sound. And would it be the case that if you have a relatively narrow band frequency, it does get quite hard to localize that sound because you want both of these? Yeah, you want that whole spectrum really in order to properly localize the sound.
That's very true. Basically. That's very much true. Let me adjust the microphone because we rely in all these cues, and it's fair to say that the dominant cue for sound localization is the interaural time differences. This is the dominant cue. If we only deliver right cues in a narrow band, then the brain may struggle, basically.
Yep.
And that's why, thanks for this question, Simon, because this is very important to explain how Amphi Hi-D works, because if we really want a very good virtual localization of spatial sound, then we need to deliver cues that are homogeneous, that deliver the same spatial information from low frequency to high frequency, from around 200 hertz to 12 kilohertz. If we are able to provide the right binaural cues, the right HRTF rendering in this frequency range, we are going to have very good spatial audio. Otherwise, the spatial audio image is going to be compromised. Okay, and this is what Amphi Hi-D does. By using multi-channel speaker arrays, we are able to provide high crosstalk cancellation over the important range of the spectrum that is relevant for spatial audio, and we are able to provide what we call high dimensional audio, which is an audio experience that allows us to hear all around us, even in space, okay? Because we are now able to even render a source that sounds very, very close to us, like, for example, a whisper, And this is something very important of a crosstalk cancellation system where it works well, that when people listen to them, they say, wow, this is amazing, This is how we achieve it, by using a multi-channel array that allows us to provide high crosstalk cancellation over the whole frequency spectrum,
So in this chart, when you're showing 2, 3, 4, 5 channels, that's not a surround system with channels behind you. Those are like an array in front, isn't it?
Yeah. So this graph is actually a laptop prototype. That's why basically the speakers only work from 500 hertz, because there are micro speakers from a laptop, like this image that I have here.
Yeah.
With speakers on a notebook just in front of the user, we are able to separate the signals that arrive to each one of our ears, and therefore we are able to obtain high crosstalk cancellation. Means I can separate independently the signals that arrive to each ear of the user, and therefore, because I have these independent signals of the ear of the user, I can deliver spatial audio just with an array in front of the user.
And does it sort of asymptote out to no more advantage past about 5 or something? Is it?
Absolutely. So the more we will add, the more we will gain here at higher frequencies, by the physics of the array. We basically got like 5 as some kind of magic number, where we could achieve a good basically balance between bill of materials and between spatial audio user experience.
Right, right.
Yeah.
Mhm.
And the Amphi technology still works by using two speakers. Like most of the notebooks nowadays only have two speakers, two channels. However, you are only able to control a band pass of the crosstalk cancellation. If we really want to deliver key spatial audio cues and give an experience that we say, wow, this sounds what we say true to life, we need to employ a multi-channel array. We need to employ the Hi-D technology.
And this is this average CTC figure that we're looking at now. Is that supposed to, or is that sort of correspond to the previous graph when we're looking at the difference between the left and right ears?
Yeah, I'm going to adjust this because it's... So what this graph is telling us here, okay, is that because we are able to obtain high crosstalk cancellation over the whole frequency range, if I go to the previous slide, I'm going to be able to accurately render this information to the right ear and accurately render this information, to the right ear. This one to the left, the black one to the left, the orange ones to the right.
Mhm.
I'm able to accurately deliver these two signals to the ear. And therefore, if this is an HRTF at 45 degrees, once I deliver it with a system that provides me high crosstalk cancellation, I'm going to believe that there is a source there at 45 degrees from me, because I'm listening to the signals as if this source would be there. If we would only have two channels, we would only be able to obtain that in a narrow part of the spectrum. So the spatial audio experience won't be as accurate, But once we are able to control the whole spectrum and deliver the signal, we will have a very accurate sound experience.
Mhm.
And just for reference, we have here the crosstalk cancellation that a stereo system could basically give this dashed orange line here. So as you can see, it's much more reduced than if using a crosstalk cancellation algorithm.
Yes. Yeah.
So I hope this is clear how the technology works. I didn't want to get more into the technical details, but I think this is a good glimpse of how with the Amphi Hi-D technology we can, just with speakers in front of the user, have an experience that goes all around us.
So what about source material? So if you have standard stereo audio music that you're listening to, does it imply that there's no effect?
So, like one of the things that we are doing, if for example we have standard stereo, what we are going to do is to convolve this stereo with a set of HRTFs that are at plus minus 30, at minus 30, and plus 30. So just by listening to the laptop, we are going to deliver the virtual cues. If I would have a virtual speaker 30 degrees to my left and a virtual speaker 30 degrees to my right.
Okay.
And then we can place ourselves in a virtual stereo setup. So from a notebook point of view, it's very good because I can be listening to Spotify and then I can have the feeling as if I'm in the middle of a virtual stereo setup.
Yeah.
Right.
Then we have a 5.1. Please, Dave.
Oh, I was just gonna say, I think a lot of, like, if we go back to the Beatles, a lot of content has huge, massive stereo separation. But I think a lot of content contemporary, since the age of the Walkman, everything's been engineered to be listened to on headphones. So they've really kind of stopped putting so much stereo into the production. So it'd be interesting to go through a little comparison of like recordings over the years to see how it's handling the stereo or the mix.
Yeah. What really happens is like, this technology, it always tries to mimic a physical setup, the physical experience as if we would have two speakers in front of us in the case of stereo. So the more hard pan the original mix is, the more dramatic it's going to be with our technology.
Okay.
Leaving aside standard stereo audio, then is there a standard spatial audio format that what's behind that?
So it depends on the use case. For example, and I can go to the next slide. Like these are, for example, different use cases where we can apply the technology. So you can think of any application that requires speakers in front of the users can benefit of our technology. And then I'm going to show you a couple of devices later where we basically apply our technology. Gaming, for example, game audio is 3D audio because it uses HRTFs on the game engine to really provide you spatial audio. That's kind of the format. Headphone 3D audio, because in the end, this technology is virtual headphones. Virtual headphones from the point of view that we are separating the signals that arrive to each one of the ears through mid-air. Okay. Other use cases, for example, in home cinema or home entertainment, or also to a greater extent music, the native format that is more established right now is Dolby Atmos. So what we would do with Dolby Atmos is the same as in the stereo setup that we had HRTFs at -30 and plus 30. Now we will have HRTFs at -30, at 0, for the position of my side surrounds, for the position of my rear surrounds, for the position of my height speakers, and all these HRTFs will encode the positional information of the content coming from this position. Okay, and we'll give us this idea.
So in that case, it's actually like a 8-channel audio data that you're decoding into this.
So in this case, in the case of Dolby Atmos, I think Dolby Atmos, for example, in Apple Music is 5.4.1. So we are having 10 channels. So 9 because we wouldn't encode the subwoofer normally, but 9 channels with 9 HRTFs that will be mixed into a 2-channel signal, left and right. And then we will deliver this left and right with the down-mix position information of all these Atmos speakers into the 2 channels, and we will deliver it through mid-air. And this is what if you're Apple users, or also Android has it now, and basically you get the AirPods and you connect it to Apple Music. Apple has an engine that has some HRTFs and that gets the Atmos music and they code it to left and right. So what the Audioscenic technology is doing is delivering this left and right through mid-air.
Yeah.
And just to show you, this is quite powerful because now we can create, we can put our technology in PC displays. Just imagine a display that has a head tracking sensor to tell us where the position of the users are, and that has some speakers that could be down firing or front firing, like in the case of this device, and that will give us CTC. And just here for basically example, I'm putting a graph showing how this phenomena of having more channels, what is the Hi-D technology, still holds and give us better cues for basically high frequency reproduction. But that could be placed on a display. And what this is going to give us is that I'm having a display, I'm watching videos, I'm watching Netflix, I'm listening to music in Spotify, I'm playing a video game, and I don't need speakers all around me because I'm hearing like that just with the speakers in front of me.
Yeah, that's a huge market advantage. I mean, I started in electronics audio doing rear wireless speakers, and I think it was something stupid like 75 or more % of all rear speakers were never even connected because the wife didn't like the cables in the living room. But anyway, so this solves that in another way.
Yeah, I think this is one of the great advantages of our technology, that the making audio reproduction practical, basically. And then, yeah, the same in notebooks. One of the things where Audioscenic is working is towards the integration of designs in notebooks that have multiple speaker systems, as you can see here. Okay, because what this gives us is that a notebook can now just make us sound like the most amazing. I mean, the most amazing. We always need to consider that the notebook speakers are containing the experience that they provide, but very realistic spatial audio.
Mm.
And apart from that, our technology is also one of the things is fully configurable. Okay, so we have an algorithm that basically can work with 2 speakers, like what we call the Amphi technology, or even more higher number of speakers, the Amphi Hi-D technology that can be configured from 3 to 5 to, in this case, this is a prototype that we are working with for multi-user reproduction. Okay, all these systems I was talking to you about, like this one of 3 and this one of 5, were for a single user. In the lab, we are working with prototypes that use, in this case, we have here 20, we have, I think, 14 and 14, 28 speakers, and that allow us to provide this experience for 2 users.
Okay. You mentioned that you're selling IP, not the physical hardware. What's required on the hardware side of it?
So in the hardware side, what is required is ideally that we have an array of identical speakers. Okay,
Yep.
which means that you see, for example, here there are 3 speakers, or here there in the left-hand side there are 5 speakers. We would like them to be on a line. We would like them to be the same speaker, identical radiation characteristics, and also because of the physics of the loudspeaker array, we want some speakers to be as outside as possible, and some speakers to be on the center, because that allows us to control well the low frequencies that are important for the time differences, and the high frequencies that are important for the, to deliver for high frequency. Here you can see 5 speakers, 2 of them on the sides quite apart, and 3 of them on the center.
And how about processing?
How about processing? Good question. So that takes me to the next slide. So in Audioscenic we have 2 different ways of implementing the technology. One that we call host-based, and one that we call standalone. Okay. On the host-based, what we do is that for certain accessories that are going to be run as PC accessories in Windows, we run all our software in Windows, the head tracking and the audio DSP.
Right.
Other implementations are what we call standalone implementations, where we have a DSP and a head tracking system inside the device, and then we do all the processing inside.
Right.
And that has its pros and its cons depending on how we want to implement the system, basically. Yeah. And just to show you, so our technology has been, I don't know if this soundbar was out last time we talked. That was our first product. That is a product that we did in collaboration with Razer. Okay. This was released last year at CES. And this is basically the top of the range soundbar of Razer, where they work with Audioscenic to implement our Amphi technology. And this soundbar has 5 speakers and has a head tracking system. Okay. And basically, when Razer released it, they got them 12 Best of CES awards because of the experience that this gives, because of the great experience. Okay. And these basically, it's now the only way I want to hear my games. This is basically reviews that people get, because it sounds really amazing. Just with the soundbar, we are hearing sound all around us, So this is what we call the Hi-D technology. Audioscenic has also released some other products with other partners like Acer that use, in this case, 2 speaker systems. The technology is still working with 2 speakers. It wouldn't give us the same amount of realism, but still it will give us a more realistic spatial audio experience than just having left and right stereo speakers.
All right.
And continue releasing product. This year, Audioscenic is going to release a multi-channel Amphi Hi-D monitor at CES 2025. Okay. So we're working hard to deliver this product, and we hope this product is also like a very, yeah, innovative and really basically it's a use case that hasn't been developed before, like the first ever multi-channel monitor with machine learning, machine learning listener position sensing for spatial audio. So we are really looking forward to be at CES and the release of the monitor. Yeah.
So you're seeing gaming related stuff. Is that because that's something that has spatial audio source, and otherwise is not that common to have spatial audio source?
That's it. Yeah, that's very. I mean, depending what we call for spatial audio, okay? Because spatial audio, stereo is spatial audio, but it's just in front of us. Then we have things that are surround, like for example 5.1. What does have surround? The most common media is probably like videos, or films. Basically, like most of Netflix productions have 5.1. Some of them have Atmos, but the most realistic production of spatial audio at the moment are the video games. This is what gives the greater experience.
Yeah, they've got continuous kind of 3D effects in video games, whereas a lot of movies, maybe it's changing, but historically, a lot of movies in 5.1, a lot of the intro sequences, the first 10 minutes would be done in 5.1, and then the rest might not be, just because of the audio editing production cost was so incredible. But with AI, who knows where that's going?
Certainly with AI and with new, now there are like a new spatial audio formats. There is something called the AOM, Alliance for Open Media, that is pushing a format called IAMF, immersive audio media format. That means that we are going to have open source spatial audio formats that we are going to be able to distribute, to send here, to send there, and this is something where the whole audio industry and the whole basically consumer electronic industry is looking into, because that means we have tools to create spatial audio in an easier way, like for example with AI, or if we have tools to edit and distribute, and then with systems like Amphi enabled systems, being able to consume spatial audio just with a monitor, that's great, I think, there is, to me, when you listen to spatial audio, you never go back, You always want an experience which is more engaging, and that is more realistic. And I think thanks to the industry and thanks to things like Amphi, we are able to take this experience closer to the user.
Cool. All right. So, any other questions, Simon?
I think I'm good.
All right. So, Marcos, any parting words before we say goodbye today?
Well, I think I really want to thanks both of you for the opportunity and because you are doing a great job, basically with taking ideas and making ideas flow to the whole audio industry. And yeah, so thanks both of you. Maybe last remark is that Audioscenic will be at CES 2025, and if anybody wants to basically get in touch, please send an email at info@audioscenic.com. Look for us online or look for me in LinkedIn, and we'll be very happy to connect with you there in Vegas.
Okay.
Yeah, and thanks to both of you again.
Okay, thanks, Marco. Everybody like, subscribe, share, all that good stuff. And we'll see you next time.